This question asks, which method requires less force to lift the load? Is it method A, which is a class 1 lever, where the fulcrum is placed in between the load and the effort? Is it B, a class 2 lever, where the load is placed in between the effort and the fulcrum? Or, if equal, then mark C. So again, we're essentially comparing the efficacy or the mechanical advantage afforded by a class 1 lever versus a class 2 lever. And the mechanical advantage of either such lever is given by the moment arm of effort, which we can call D sub E, over the moment arm of the load, which we can abbreviate as D sub L. Now let's take a look at what each of these parameters are in each method. In method A, the class 1 lever, we see we have a moderate effort arm. So here on the left, we have the effort, and therefore the effort arm is equal to the distance between where effort is applied and the fulcrum. Then in terms of the load arm, we actually have the same value. So we can see the distance from the load to the fulcrum is likewise the same. So in this case, we only have moderate mechanical advantage provided by this class 1 lever system. In B, we have something quite different. So first, let's take a look at the effort arm. So here on the far left, we have the effort. So the distance from the effort to the fulcrum is much larger, at least compared to A. Now, we can also consider the load arm in this case. So here we have the load, and here we have the fulcrum. So we have a very small distance, a very small load arm for this class 2 lever. So because in B we have a larger effort arm and a smaller load arm, that means we have much more mechanical advantage using method B than method A. And this means method B will require much less force to lift the weight. And the correct answer is B.